Did you know that a father's eating habits, even before conception, can affect the fertility and metabolic health of his children, and even his grandchildren? Today we're going to explore an innovative and emerging concept in science: inherited testicular metabolic memory and the intergenerational effects of a high-fat diet. Let's explore it. Recent experimental evidence show that obesity, a diet rich in saturated and trans fats, and poor lifestyle habits directly affect male reproductive function. This affects sperm quality up to 2 generations. Compared to a healthy diet, sperm quality is much better up to the 2nd generation. In murine models, the exposure to such dietary patterns can significantly impair key sperm parameters, including motility, viability, and morphological integrity, indicating a functional disruption of spermatogenesis. The most concerning aspect is that these deleterious effects on sperm quality can persist even after interventions, such as weight loss. It suggests that the damage induced by lipid-rich diets is often irreversible. This phenomenon supports the concept of metabolic memory. And how can we define it? The testicular metabolic memory is nothing more than the persistence of molecular alterations, even after normalization of metabolism. In sperm, for example, it is caused by HFD. These changes are not alterations to the DNA itself, but epigenetic alterations, as in ways of controlling how genes work. As if the body turns on or turns off genes without changing the structure of its DNA. This can happen through chemical marks on the DNA such as methylation, modifications to histones, proteins that help package DNA, or through the action of non-coding RNAs. And according to the studies, what epigenetic changes have been observed with the consumption of a high-fat diet? MicroRNAs, such as MIR19B and MIR34C, are small pieces of RNA that help control how genes work. They have been identified as important for assessing sperm quality and can influence the development and health of the next generation. In addition, obesity can activate mechanisms in the body linked to inflammation. These include proteins such as JNK, which helps initiate inflammatory responses, and nitrogen monofluoride kappa B, a transcription factor that controls genes linked to the body's defense and cell growth. This can lead to more stress and inflammation in the testicles. In tests with mice, consuming a high-fat diet caused the sperm, the subject of the study, to move less, falling from 53% to 43%, and to have more changes in their shape. Even when the animals went back to eating healthily, the bad effects continued, especially if the fatty diet was during puberty. And what about the chance of pregnancy? It also decreased, showing that fertility was indeed affected. These changes don't just affect the animals that ate the high-fat diet. The offspring and descendants of these males also showed problems with their metabolism and reproduction, such as low sperm count and defects in sperm structure, even though they never ate this diet. In other words, the effects can be passed on from father to son to grandson, like an invisible inheritance that crosses generations. This is called the transgenerational effect. These results are related to advances in reproductive well-being, since they will have an impact on new generations. Science is increasingly showing that men's reproductive health is directly linked to their lifestyle habits. What we eat, for example, doesn't just affect us, it can also influence the health of our children and even grandchildren, as we've seen with transgenerational effects. These findings reinforce how important it is for men to take care of their diet and health before they even think about having children. It's not just about fertility, but about leaving a legacy for generations to come. Thank you for watching this far. We hope you've learned a little more about how the health of the testicles can store memories of the body's experiences, such as food, and how this can be passed on to future generations.